I will try to take you to my story of catching a bus. So, first of all, I am a PhD student at Dublin Institute of Technology, and I am a part of a tPOT group. So tPOT stands for Toward People-Oriented Technology. So we're actually coming from Russia. No, I'm joking. So we are kind of the communists of research in one way, but we are promoting or the usage of energy toward the good of people. So I am interested in data analysis using Python, R, and machine learning and process analytical technology. So that's me. So why I'm giving this talk, it's actually when I was trying to do the presentation, I was looking for like how big the data is generated in real time. So I just actually type in, when I was Googling, like what data are we generating? Probably this is each second, each minute, or each hour, I don't know. But if you type this website, you will see this web page. So you have, so if you start from the corner of the rectangle, you have like Twitter. So there is like 324,000, almost 400,000 tweets. And there is like 131,000 video uploads. So there are a lot of data generated in the web. So this actually presents two things. So we have a challenge. So how to handle this data, how to deal with this data. So each company has different like platform. They have different communication protocols. So it's actually a challenge to communicate through the web. And the other thing is an opportunity. So if you could make leverage, as they say, leverage this data, probably you could make a business or something beneficial for people. So back to catching the bus story. So imagine that you are at home and you want to catch a bus, and then you check your phone and you say, next bus is in 8 minutes. So you run from home. So the bus is coming, you keep running, and then you miss the bus. So you check your web phone, or you check your mobile phone, and then you check like the web service related to the RTPI Dublin bus, and it tell you it's in 40 minutes. So you have to wait 40 minutes in the bus stop. It's kind of a waste of time. It's not maybe a good joke, but so if you had some kind of smart algorithms with your web app to help you predicting the right time when, or like giving you like an accurate prediction of the bus time, it will be maybe more, it will add value for the app. So there is a need to have like algorithms that will analyze like the data, and will have kind of a smart prediction for the bus arrival time. So you'll be happy, then you will catch the bus. So in general, actually, data mining would be like something very necessary in each web app. So in the future, I would say that each API would have some kind of components related to data mining. So you have smart API instead of just an API that just extract data from the internet. So So actually, it will tell you not only the data itself, but it will extract other layers of information. So it will let you know about the patterns, how how the user is behaving. So probably it give like companies more idea about user habits. And then it will predict many things, such as the pastime. So there are many data mining algorithms. So there are clustering, neural networks, Bayesian networks. But actually, I will just use one algorithm, that is the Bayesian network. While I don't have any reason for choosing Bayesian network for this example, it's just something to play with. So a Bayesian network. So Bayesian network is a graph. So in this example, I took a graph. So we have rain, you have the sprinkler on, and then the wet grass. So it's an acyclic graph. So if you start from one node, you will not get back again. And so each node have some kind of probabilities. So like in this graph, you have the rain, and so the rain, and then is like the parent, and the sprinkler on is like the child, and whether the grass is wet or no, it's like the bottom of the graph. So you could see that if you start from the rain, you will not go back to it. So it's not a cyclic graph. Sorry about this. So, thank you very much. Thanks. So the Bayesian network, as I say, is like a cyclic graph. So yeah. So the Bayesian networks, you have like nodes and you have edges in the graph. So the nodes are, I think you are familiar with the Bayesian network, are you? Or everybody? No? So the Bayesian network, you have nodes and edges. So the nodes represent like the random variable, and a random variable, each random variable, like there is some kind of probability. And the edge represented like the dependencies between the variables, and the dependencies are kind of represented by the conditional probability, so by the Bayes theorem. So if rain affects or like determine whether the grass is wet, as well as the sprinkler. So is this clear a little bit, or yeah? So one of the advantages of Bayesian networks is like it allows the combination of information from different sources. So so the nodes, you have like some kind of freedoms. You could put continuous, discrete, random variable in each node, and then you could make your graph as big as you want. So it's actually have some kind of computational burden, but still you could make your model as complicated as you want. So that's what advantage of Bayesian network. And the other advantage is like it represents like the interaction of variable in your model. So you see how the variables interact with each other through these dependencies or conditional probabilities. So the conditional probability is just Bayes' theorem, if you remember from last presentations. So Bayesian network, it doesn't tell you specifically what to do, but it just give you a probability. So it's up to you to make the decision. So it depends how you decide to make the decision. So the reasoning pattern in the Bayesian network, so you have three types of reasoning. So you have the causal reasoning. So the causal reasoning, you have so you have something that's happening in the parent. So for example, in our graph, so you have like you see that it rains. So this information propagates from the parent to the child. So this way of reasoning is called causal reasoning. And you have the other type of reasoning is called the evidential reasoning. So the information propagates from the child to the parent. So it goes, so if you see the grass is wet, so this information will actually propagate both. So it could either rain, it was either raining, or the sprinkler was on. And then you have the other reason, you have intercausal reason. So in this case, like the information goes both from the parents and the child. So this is a little bit about theory. So I found this libraries in Python. So I found BasePy, GPy, BnFinder, and libpgm. So actually, they all deal with Bayesian networks. Probably there are more, I don't know. I think most of them deals with continuous data. So for me, it was easier to deal with libpgm. So I picked libpgm. It was really easy. So it had like many functions that suited my problem, and also it dealt with discrete case. So the library requires NumPy and CPy and Python 2.7. And I just took this from the website, so you could just log into the websites and read more about different classes and library. It contains a class method for discrete, continuous, and hybrid Bayesian network. So the input files are in JSON. So if you want to put like this information about the graph into the in your program, you write a text file and you put the data as JSON format. So JSON looks how it looks like. It looks like that. So if you have this previous graph, so if we have like rain, sprinkler, grass wet, so you have like you write like your vertices and then your edges. So you have grass wet, rain, sprinkler on as a V. So it's V stands for vertices and E for edges. And then you write your nodes data. So you write like the node. So for example, sprinkler on, so you have the order, so it's 1, number of outcomes, so you have either true or false. And then you write the parent, child, and then the probability distributions. I think it's very straightforward. So if you know your data, you just put in like this information into JSON, and then you could start doing some magic. So I go back to my problem, is catching the bus. So I have to sit in a coffee to get the prior, because you know Bayesian network depends on the prior. So I sit for a few hours in the coffee place, watching the bus while I was writing like a Python scripts that reads the web data from like the RTPI API. So I sit actually, I choose the time so that I sit like in the morning, weekend, and also at different time, like when it's bad weather, nice weather, and so on. Maybe it's not really the optimal way, but so actually I had a very simple idea. Is very simple Bayesian network. So it's just your API and then the predicted bus arrival time. So it's just 2 nodes. So For the web service display, so if I just type in, for example, if you have bus 46A, so if I type it, you have like a probability either you will get in 2 minutes, 4 minutes, I don't know, you could get maybe 10 minutes, I don't know. But in my case, I simplify the problem, so I just put like intervals. So if you get 1 minute, so it's like between 0 and 2. If it's 3 minutes, it's between 2 and 4, and so on. So I make my problem discrete, or my variables discrete. And I choose to have the same probability. So when you open your web, it will tell you either 2 minutes, 3 minutes with the same probability. So, and then when you read the web, so what is the probability that the bus actually will arrive at this time? So after sitting for a few hours in the coffee place, I got this prior probability. So this is like the Joan probability between the bus arrival time at the web and the predicted arrival time. So well, I don't have much things to say about it. So I put actually this data into the JSON file, and the library libbgm have some functions. So the function that allow you to store or like to calculate like the posterior probability. You know, like in Bayesian, you have prior probability and posterior probability. Is tcpd dot conv prob ve. So this function is stored in a class called tables CPD factorization. Do you see it? Do you see it? Or it's actually, this code just allows you to get the probability of bus arriving in 4 or 6 minutes. Yeah, just 3 lines. So this function just holds like the graph structure, the nodes and the edges, and the one that calculates or updates the conditional probability is the one there, quantprob VE. So this is the data structure containing the vertices and edges. So it's stored in discrete Bayesian network class. This is for updating the CPD. So is this enough? Like when you run this program, like the network, you will have probabilities. Is this what you are looking for? So you are still undecisive what to do. So actually, decision making is another science. So you could either choose like, okay, I would be like sure, so I will take I will go like in 2 minutes, or you could take some risks and go like when you know like the bus will arrive in 40%, 50%, or you do like confidence interval 95%, as they do in statistics. So. So actually, making decision is another story. So, well, you also could do a dynamic Bayesian network. So it's a variant from the discrete Bayesian network, and actually it relates the graphs, the same graph is related to the other one just in time. So T1 is like maybe 0 minutes, and after 2 minutes, you make a new graph and you relate to the previous graph through the edges. And I found this very useful because if you read the web, it says the bus will arrive in 5 minutes, and then after 2 minutes, you read the web application, and it says the bus will arrive in 5 minutes. It means that the bus will be delayed for sure, because there will be some maybe accident on the road. You never know. So actually, you could do this in. You could actually store this structure in Python. So you go back to your JSON file and you just add. So you have like two like beside the nodes and the edges, you add just like two thing. So you add the initial v data. So this is like the initial discrete Bayesian network. And then you add the two TBN v data. So this is like the networks that hold like the past graph. So actually, I implemented, and then I just ran it while sitting in a coffee place. So I was watching the bus stop, and then like I read like this information from the web services. It tell me that the bus will be in 4:06, and then it updates after 2 minutes. Then I got between 2 and 6, and it was like, actually I'm looking for bus 46A. So now it's in 2 minutes, so it says between 0 and 4. And then in a short while, and then the bus actually was there. Well, it says that it's between 0 and 2 minutes. Actually, I had some output, but it's depend on your way of making decision, whether you want to make more risks or less risks, and so on. So it is a simple network. It's just like, I just started actually doing the PhD, so probably there are more to the story of catching a bus than just 2 nodes. There is like additional nodes. So it's a question now. So what are the parameters or the variables that could affect the bus arrival time? So what do you think? Huh? The tram? Traffic, yeah. And? Yeah, the number of passengers, maybe. Yeah, weather, yeah. Yeah, actually, weather and traffic is, yeah, like the time of. Oh, yeah, like the which it is, if it is the first or the second. Yeah. Oh, very good. Yeah, I will maybe add it for the next PyCon 2016 or something. Yeah.
Opportunity lost. So taking the bus to the cinema is a lot less. Like you point to go in that case, and but if you're going to a job interview,
yeah,
there'd be that would have an impact on your what probability would be.
I see. Yeah, like going to somewhere like not frequently
Value. So somewhere where there's more value.
Oh, okay.
Somewhere where there's less value.
Oh, I see. Okay, yeah. Yeah, maybe I could put this next time. So, yeah. So for the moment, actually, I thought about, as you say, just traffic and weather. So probably I would have to make new nodes for the traffic and weather. So, but like I don't know the relationship between these two nodes. So, well. I kind of heard about something called the constraint-based approach, and so if you have like nodes like that, so how to establish the relationship between them is, of course, like if you are a statistician, you will think about the chi square, like like the chi square to establish dependencies between two variables. But of course, there are like other methods to establish a relationship. So if you establish first the relationship between two, nodes, so you have like a graph, but it's not directed. It's still like without direction, without arrows. So you need to direct it. So there are a few algorithms that actually I'm not familiar with them very well. Like the algorithms that optimize the direction, the graph, like, so it's actually an optimization algorithms, especially the method called score-based approach is like an optimization algorithm. It's like constructing many graphs and then calculating like the conditional probabilities and then giving a score to each graph, and then they took like the maximum. I'm not really familiar with the algorithm itself, but I'm of the sort of people that use the black box from the library in Python. So you could do like me, or you could. Just this tree code allow you to construct a graph. So you do first establish the relationship between two variables. So if you have two nodes, X and Y, so here is like the weather state, traffic states. So you could call or load your PGM learner class from libpgm library. And then you could do the chi-square test using discrete conditional independence. So it gives you the chi-square value and the p-value. So, like the p-value, if it is less than 0.05, you reject the test. If it is more, you accept. So, and then you just call like the optimization algorithms to calculate like the directional graph. So results will hold like the direction, the edges. So that's actually for the Python or the machine learning story side. Do you find it very interesting, or? Yeah. So it's like this library actually I found it very simple. So it's made my life very easy to calculate like the conditional probabilities, and you didn't have to go much theory. So. So actually, the other part of the story is like how I did access this information on the web, like how I did access like the time of the bus arrival. You are familiar with this, like the web services of Dublin Bus. So if you are familiar with the SADS library, are you familiar with the SADS library? It's like a SOAP client. So the thing is that you have to know the WSDL address. I didn't know actually the WSDL address. I just did Google WSDL page, RTPI, and then I got it. So like this morning I went to open data source, and there was like a web page with like the governmental open data. So probably it was there. Next time, if I want to do any service, I will check this web page. So I just enter the bus stop, and then this actually page is like an XML file. So the XML file holds all the information about the real time of the bus. So it's another problem actually. I don't know which function should I call. You see here like the last line of code. So result is equal client dot service dot get real time stop data. I really didn't know what like about this function. I have to check the. I have to check the WSDL page. So I have to go like manually and check. Okay, it's called get real time stops, and then I call it from my program. So I wonder if there is some kind of general way to call transport like web services. Is there any? No. So you have to check the XML file and.
Pretty sure there's a stop UI or something like this you can use to point to the WSDL.
Okay. All right. Yeah. Yeah. I have to talk to you. Yeah. So this library allow you to access the data in this WSDL page, and then it turn you like actually JSON format output. So the JSON format output have a lot of data about the bus stop, the different routes that are stopping the bus stop, and also like the for each bus actually have kind of a reference, a vehicle reference. So actually you could track the bus on the routes wherever it is. So there is actually a lot of information. JSON is very good because Python has the dictionary data structure, so it's easy to handle a JSON file. But if you don't know really what structure is inside, so you kind of like just plug and play and see if it works or not. So this is the data returned in JSON format, and there's another way actually to extract this information is through urllib2. So actually you just extract the whole XML file of the API. So you just extract the whole thing, the whole page, and then you try to parse. So you try to find where the data is. So I found this actually probably better way to parse documents or data from XML. And it's called Beautiful Soup because it's a soup. Like an XML file is a soup. So you also have to do some job before you extract what you want. So it's not really very practical. So this is actually the address of the API. So there's not actually a way to. I found another library, but I didn't use it for the bus. I use it for the weather, and I found it's very easy to use. So I use it for extracting the weather information, and like there are a lot of weather API. Like the most famous is AccuWeather, Yahoo, and so on. Have you been to St. Peyton? No. No. So the library that I used for this is called requests, and actually it's just like 3 lines of code, and it's give me a JSON format. So it was so nice actually. So by the way, you need for most weather you need like a key. So it was really easy, like 3 code, JSON, and then you have the information about the weather state. So this is actually the web page for the AccuWeather, and you have like here the key. So I realized that people for communication protocol between like web services and like devices, computer or mobile, categorize like the communication architecture into 2 categories. You have like the SOAP, and then you have like the REST. So the SADS is actually classified or categorized into SOAP architecture, and the REST is like a REST or REST is like another one. So urllib2 and requests are REST design, communication design. So well, I found that request is like the most simple. So it's an Apache HTTP library. So it's just use the HTTP protocols like get, put, delete, post. So that's basically it. It's a short story, but I hope you got something out of it. So I found that Bayesian networks is very flexible because you could incorporate different variables into predicting like the bus arrival time, and probably you have a better idea in calculating the prior. Do you have any idea about calculating the prior probabilities? No? Do you think I did the best way, or maybe near the best? Because I think like when you look up into the first, like the slide with the nodes, we have like 2 nodes. You have like if you have the web, like the node containing the web service. So if you type the web service, you could have either 2, 6, 8 minutes, So probably I could change this because some buses are more frequent than others. And also this is depending on the time. It's depending on the time. So sometimes you have more buses than. So if you take your mobile phone or your computer and you type in the bus number, so we get maybe the bus is coming to 3 minutes or so on. So the frequency kind of play with the prior probability that you choose for your first node. Anyway, that's what I'm thinking now. So and yeah, I have to add more nodes. So. And there's another problem. Like when I was sitting in the coffee, sometimes I got disconnected because the internet connection was not good. So how should I deal with this problem? So the Bayesian network is good for that as well because I don't have the information, but I could have some probability to make up for this absence of information. So if I have good prior, it will kind of leave me I could actually deal with internet or not connection to the internet or bad internet connection. It's very important for me, internet connection, because my field of work, actually I didn't say that at the beginning, my field of work is in disabilities, is working with people with disabilities. So people with disabilities, they wouldn't make decisions for themselves. So I have always to be not to be, but the system have to have some kind of safe response to different scenarios. So, and yeah, that's making decisions is part of it as well. So I have to make I have to help them in their daily life. So making decisions is very important, because if I make the bad decision, if something tell them, okay, you could throw yourself from the bridge. If a system tell him this, he shouldn't do that. So making decision is very important for me as well. So, and well, for requesting the information from the web, REST with the JSON format was actually the best. So if you have something with JSON format, it's really good. So it makes life very easy. So, yeah, okay, that's, I hope I, yeah.
Thank you. Do you have any questions? Do you want the mic?
Okay. Time of day, 9 a.m. versus 12
Yeah.
a.m.
Yeah.
Is that going to be part of the input, or would that be something that is output? Give different probabilities for different times of the day?
Oh yeah, it's part of yeah, the input actually. Yeah. Yeah, I mean, for now I didn't care much about the time. I didn't put the variable related to the time, but in the future, network I will have node that will kind of both give me a good accuracy of the prior. So if I have not saying to me that's it's 9 o'clock, so the probability that the web service will tell me that the bus is coming in 5 minutes will be more than if I put in 12 o'clock and they say the bus is coming in 5 minutes, will be less probability. So yeah, I have to put a node on the top of the the web node. So yeah, is it okay?
Sorry, in the actual API where it gives you the expected time of the next bus,
Yeah.
if you were to collect all that data, could you actually work out when the bus actually arrived over time? Because if it says the next bus is due at 5 minutes, this
Yeah.
will stop at 5 minutes, 5 minutes, 1 minute,
Yeah.
and then it drops off the page,
Yeah.
then you know it's arrived.
Yeah.
So you wouldn't have to sit in coffee shops all the,
Yeah.
for every bus route.
Yeah.
I don't know if that's how the data works. Would that be possible?
Yeah, I would say maybe. I just want to make sure. That's why I just want to make sure, because you never know. Maybe there's a delay in communication between the actual arrival. I know that the bus has a GPS system that communicates with the like with these smart little posts. And I think there is like not all the stops have this machines, so probably like it's some kind of even I would say predictions. They also do prediction. So maybe I'm doing a prediction on a prediction. So
Well, having said that, I was
yeah.
at a bus stop last night, which said the bus was due in 4 minutes,
Yeah.
and then it just told me it just jumped to 44. The bus never turned up, so
Yeah.
the relation's probably not very good.
Yeah. Yeah. That's good with the dynamic, because like if you have one time and then in 2 minutes it tell you 44 minutes, it means like there's some problem. Yeah. There's actually another way of doing that. I actually at the beginning I didn't do that like this. I kind of track the bus. I see where he was, and then I kind of estimate the time between bus stops. And to estimate the time between each bus stops, I kind of did Bayesian networks to based on the weather, different traffic road. But I decided to go with this way. So yeah.
Just want to mention doubling, DUBLA and KED. That's another possible source for the real-time data.
Yeah.
But I think they're kind of a clearinghouse for that sort of open data.
Yeah.
In case anyone else
Yeah. Oh, thanks. Thank you very much.
How did you find the SUTS library to work with in general, and how reliable did you find it retrieving from web services?
Yeah, they're good actually. They are good. Yeah, stats are good because it gives you like the JSON format, so it's good. It's just I guess it's depend on how the information is stored in the WSDL. Yeah, I think I found it very good. Like yeah, sometimes if the connection is not good, like it's kind of break down. Yeah, I have yeah. So yeah.
Have you talked to Dublin Bus themselves at all? Because I mean, they run their own surveys on
Yeah.
time to time. So.
No, actually, I didn't talk to them, but it's on the time. I want actually to try by myself first and see what information I will need, and then I will contact them. So yeah.
Do you have any experience with IMC? How does it compare to the latest?
I just can't. I was just looking for specific information. PMC, if I know, it's more continuous. No, is it like? I think it's more continuous. So yeah. Yeah, I had discrete. I decided to go with discrete variables, so it didn't suit me. I found it like when I was trying to find like a suitable library, I was actually looking for like specific. I need a library that calculate like the probabilities, distributions, make the construction of the graph. And when I was reading the document, it was like long and lots of theory. So for me, the simpler one was the libpgm, and also libpgm is related to a Coursera course, actually. It's related to a Coursera course, and actually I saw like some video from the Coursera course. It's very nice. Person is like Collar. If you ever know, she's doing like a class about Bayesian networks, Collar. And she actually wrote, or actually her video is related to the one with the constraint base, like to construct the network. So, yeah. I mean, I went with the simpler option, so yeah. Yeah.
What's your next project?
No, I'm still going on this. It's still finished, not finished yet. So yeah, so just making the graph more complex, and yeah. So yeah, and actually this will be part of project of like aiding the people with intellectual disability. So like both like weather and bus prediction time is very like important components. So.
Are you planning to give this as an open source application?
It's not really a big program. It's like it's just yeah, it's just like a small component, yeah. Because this will be involved many people. It's not only me. So me, other people. So I have to talk to them. So yeah.